So a few years ago, my collaborators gave me the mission to answer a very debated question, the question of subduction initiation at passive margin. And I'm not sure I can answer the question, but I can at least contribute to it. And as I am a geologist, here I will focus on the rheological conditions for subduction initiation. Yes, and as you can see, it's an extremely debated subject. And it was even more in the recent years with the development of numerical capabilities. And the reason is simple, we still don't really know when, where, and how subduction initiates. And the problem is the same for decades. It has already been presented in the previous presentation with the aging of the lithosphere. The stress required for failure of the lithosphere is way too much and is not representative of the force observed in plate tectonics. So spontaneous subduction initiation at passive margin is quite difficult, and we need to look at other mechanisms. And a lot of people investigated the feasibility of subduction initiation. And if we don't really know where and when subduction initiates, we still have some facts. And first, that subduction is extremely fast. Most initiation events are proximal to pre-existing subduction zone. So it means that it probably requires external forcing. And the last fact is that 90% of the worldwide trenches are located at less than 200 kilometers from continental margin. So it also suggests that there is also kind of control from the passive margin. And how those subduction initiate, we also don't really have an answer for this question, but we have a lot of different models, both in intraoceanic domain and at a passive margin setting. And in case of passive margin inversion at a passive margin, we have the model of lateral propagation from one ocean to the other one. You saw this model with the presentation of Zhao. And there is also the forced subduction initiation at a passive margin, so the inversion of the passive margin. And we mainly focus on this model, because we need to start somewhere, and also that's the model that is presented in the Wilson cycle. So we try to test the feasibility of this model. What is clear is that it requires two stages. First, the deformation of the crust, which is controlled by the strength of the lower crust, and then the deformation of the mantle lithosphere. And it is relatively clear that the mantle lithosphere play a huge role on the mode of subduction initiation. And it's inferred by both analog and numerical model. And you can see from the left to the right, we increase the strength of the mantle lithosphere, and we pass to a mode where subduction is intraoceanic, to a mode where subduction is at the passive margin, and the last case is lithospheric folding. And probably even more important is the shape of the passive margin. And when I'm talking about the shape, it's in particular the depth of the thermal boundary. And in fact, with a model with very long step at the margin, it requires much less tectonic forcing. So that's the model, for instance, of this study, Zhong et al., 2019, where the passive margin is relatively hot and a bit weaker. But with passive margin with strong lithospheric mantle and the linear interpolation between the ocean and the continent, it requires much more stress. And the thing is that this configuration is a result of the mode of continental rifting, and it's extremely difficult to evaluate. And probably even more important than the thermal age is the difference in strength between the lithosphere at the ridge and at the margin. And here I present a model where we first apply a period of cooling, and after we apply some convergence with defined velocity. And the main difference between the two models that I present in this slide is the age of the oceanic basin. So on the left, we have an oceanic basin of 30 million years. So that's basically the age at the passive margin. And on the other side, we have a 60 million years passive margin. And it is clear that a young oceanic basin is more likely to be inverted. And the reason is that it does require a long period of cooling to reach thermal equilibrium. And in the second case, the difference in thickness is too high and the basin requires much more cooling time. After looking at the lithospheric mantle, we can also look at the mechanism of subduction initiation at passive margin. And actually, the subduction at passive margin require, as I say, the deformation of the crust, but it require more like the formation of a décollement at the base of the lower crust and the transmission of the deformation to the lithospheric mantle. And this transfer of deformation is possible by the joint effects of the sheeting inside the spiral crypt deformation domain. And it means that there is a huge role of crust-mantle coupling, decoupling for the success of subduction initiation at the passive margin. And here I present 4 different models. These models have exactly the same boundary condition, but we change basically the material in the continental crust, and it will influence the crust-mantle coupling at the passive margin. And from top to bottom, we pass from a model with strong or like a very high decoupling between the crust and the mantle to a very high coupling at the bottom. And we see that the chance of subduction initiation is much higher when the crust is strongly decoupled from the mantle. And the thing is that we can compare such model to the 2 different classical type of passive margin. And we know that the rheological configuration of this model results from different tectono-magmatic interaction and melt production during the continental breakup. For instance, on the left side, we have the model of magma-poor passive margin, and and the lithospheric stretching is driven by tectonic forcing, with little influence of decompression melting during the rifting event. And it produced almost no volcanism. This type of passive margin exhibits an hyperextended domain with quasi absence of lower crust and mantle exhumation associated with serpentinite. On the right side, we have the volcanic passive margin or magma-rich passive margin, which result of magmatic forcing, and it is formed by mantle opening of a hot melting lithospheric mantle, and it will control the extension during rifting. After cooling, these type of passive margin are highly intruded and are relatively strong. And we try to implement these 2 different models in our numerical setup. So we didn't go too far in complexity, but we try to include the different elements of these 2 type of passive margin. And we also have the same boundary condition, but here we have different coupling, decoupling condition for the crust and for the crust mantle decoupling. And it results from the key element of these 2 different models. And the magma-rich, yeah. And for the case of the magma-poor margin, we include the necking of the margin and also simple serpentinite, which results from the exhumation of the lithospheric mantle. And if we look at the strong profile, we can see that this serpentinite layer induces the decoupling of the crust from the mantle. For the magma-rich model, we consider the intrusives with a mesh at the passive margin and the extrusive at the top. And in addition, we have also mafic rheology, which strongly strengthen the passive margin and create a cross-mantle coupling. And we see that these two models are correlating with the cross-mantle coupling at the passive margin, because for the magma-poor passive margin, we produce deformation in the crustal layer, and then it will propagate in the serpentinite layer, connect with the necking domain at the passive margin, and transfer the deformation in the lithospheric mantle. For the magma-poor passive margin, the strong cross-mantle coupling created by the intrusion and extrusions will prevent the localization of deformation and will permit the migration of deformation in the oceanic domain. And we try to connect that with a subduction initiation event in the alpine realm. And we know that there was two different events in the Alps. The first one, we'll take the example of the Dinarite and the Varda Ocean. We know that during the rifting, there was widespread volcanism or magmatism along the Adria and Dinarite margin. And the closure of the ocean results in intraoceanic subduction initiation and abduction during the late Jurassic. If we look at the Western Alps, we have very little magmatism during rifting, and the margin has been characterized as magma-poor, with also mantle exhumation and serpentinization at the ocean-continent transition. And in this case, tectonic reconstruction suggests that during the closure of this ocean, subduction initiated at the passive margin. And now I will conclude, and I will have to say that subduction initiation may be possible at passive margin, but under very restricted conditions. Spontaneous subduction initiation is probably very difficult because we need some kind of external forcing. Subduction initiation is also possible for shortening of a young oceanic basin at low rate, and successful subduction initiation furthermore require cross-mantle decoupling or efficient weakening mechanism. And promising site for subduction initiation are the magma-poor extended passive margin, where we have exhumation of the mantle lithosphere and the serpentinization. And thank you for your attention.
Thank you, Antoine. There's time for one or two questions. I don't see hands or signs. I would have a question. Oh, Derek. Derek, go ahead.
Yeah, thanks. I guess I've got a question from an observational point of view. Sort of from a global point of view, are the oldest ocean lithosphere that's not subducted, is it magma-poor or magma-rich? Because maybe that gives some insights into how easy it is to subduct these types of margins.
Sorry, I didn't understand your question. Can you repeat, please?
Is on a global perspective, are the passive margins that are not yet subducting, are they magma-poor or magma-rich?
Yeah, there is not really a pattern for the actual modern Earth. And as I say, it's very difficult to answer the question. Here, I really try to take a simple model of subduction initiation, and I take the classical one, and try to see if the rheological condition can influence subduction initiation. And in modern Earth, I don't really have any example. Maybe you have also more insight about it, but the most studied of the orogene is the Alp, and we try to use this example because it's clear that we have two different oceans and very different conditions for the rifting, and we have also two different subduction initiation events and mode of subduction initiation.
Yeah.
Okay, thanks. Rune Larsen.
Yeah, hi, Antoine, and thank you very much for a fantastic talk. Let me see now. What was my question? Yeah, I mean, of course, I'm thinking about the Norwegian margin as we know it today, and obviously it's very well studied with lots of seismics. So here we're looking at an hyper extended, quite thin, and very magma-rich volcanic margin. I mean, why? Okay, stupid question. I'm not a tectonicist, but I mean, why don't we have subduction outside of Norway?
Yeah, that's
sorry.
Yeah, that's a good question. But the passive margin in Norway is also strongly volcanic, no?
Oh yeah, it is. Yeah. You bet.
Yeah. And I'm not sure I don't know if the tectonic forcing is sufficient. There were a lot of studies about how the plume could induce enough forcing to create subduction initiation, but I'm not sure that it's really enough. So in this case, we are really talking about very strong tectonic forcing. So in the order of 10 teranewton per meter if we integrate the stress in the lithosphere. So it's quite high. So I'm not sure that in Norway we reach such condition to create subduction initiation. And the volcanism also in the North Atlantic margin can also strongly prevent the subduction initiation of the passive margin.
Okay, thanks. I think that was a good question answer. Thanks.
Gwen, you have a quick one, and then we have to wrap up.
Yeah, a very quick one. So yeah, on that slide, we can see that you have models where you tested the magma-poor version with the exhumed mantle window. My question is simple. Have you tried scenarios where you have really huge extended zone of exhumed mantle, serpentinized mantle, something like 200 kilometers wide or really huge one? Did you try that?
What do you mean a very wide zone in terms of...
Just the width of the zone of exhumed mantle that is serpentinized? Did you try some scenarios with, for example, 200 kilometers wide?
You mean in the oceanic domain?
No, in the margin. On your left-hand cartoon, you have that zone where you exhume the mantle dark green with the serpentinization.
Yeah.
Yeah.
Well, I also tested the model where I have much longer passive margin. So I also try to test the length of the passive margin for the mode of subduction initiation. And the length of the passive margin will also strongly influence the chance of subduction initiation. And the shorter passive margin will facilitate subduction initiation. So also with the serpentinite, but a very long passive margin will prevent subduction initiation. Because we really need the formation of this décollement at the base of the lower crust. And in case of a long passive margin, actually the angle of the passive margin is too low, and we don't create the transfer of deformation to the lithospheric mantle.
Thanks.
Okay. I see there's a question in the chat. Jean-Christophe, you want to ask this quickly before I finish off?
Yeah, sure. Thank you very much. I'm not sure it's going to be a very quick one to answer, but looking at all the talks, it sounds like subductions at initiation at passive margin is quite a stress involving process. So I was just wondering, we saw that the only subductions that we have around the Atlantic Ocean are really remnants of older tectonic context. Do we actually think we have the stress, or has that been calculated? We have the stress conditions to actually initiate new subductions in the Atlantic, considering that we have, at the global scale, big free margins that are ongoing subductions on all the surrounding of the Pacific. Are we just seeing two or three subductions kind of dying out there in the Atlantic, or do we have the stress to create new ones?
Yeah. I'm not sure about the Atlantic. I think if there is one place where it can initiate, it's probably along the Portuguese passive margin, as Joe mentioned. And I said at the beginning that we clearly need tectonic forcing, and the subduction events are very close from former subduction. So we need some tectonic forcing from slab pull or collisional events. And in the case of the Atlantic passive margin, it's probably happening only like in very specific location, either in the Caribbean, in the Scotia Sea, or at the in the Alboran domain.